In this video, you will learn how to factor a difference of two squares. Difference of a square means a perfect square minus another perfect square. So a perfect square is something times itself. For example, a times a, which equals to a square. So a square is a perfect square. Or b times b is b square, so b square is a perfect square. So if I square root of a square, I'll get a. If I square root of b square, that gives me b. So difference of a square is basically a rule or an identity which says a perfect square minus another perfect square equals to square root of the first one minus square root of the second one times square root of the first one plus square root of the second one. So a square minus b square equals a minus b times a plus b. This is difference of a square rule or identity which you need to know. And if you want to prove this, this is basically you can just multiply this two bracket and then prove this. You will end up with the left side. So let's do that. Let's FOIL it out. So a times a, that's a square minus plus ab minus ab minus b square, ab and positive ab and negative ab, they cancel out. I will be left with a square minus b square. So that's the left side. That's we just proved it. So this identity is always true. And something else I need to mention here is you can write this a minus b times a plus b or a plus b times a minus b. They are the exact same thing and there's no difference between them. So both are correct. So let's see how we use this difference of a square method to factor algebraic expressions. Let's take a look at this one. I have x squared minus 36. So the first thing we need to do is basically we need to recognize this as a difference of a square. How can we do that? We need to check if this is a difference of two terms which are perfect square. So I have to check if this term and this term both are perfect squares. X squared is a perfect square. It's just x times x. It's a perfect square. So if I square root it, square root of x squared, that gives me x. So how about the second one, 36? If I square root 36, that gives me 6. Or in other words, 6 times 6 is 36. So I know 36 is a perfect square. And based on this identity or difference of a square rule, I can say this equals to, first of all, I can rewrite it. Instead of x squared minus 36, you can do this, not necessary, but you can rewrite it as x to the power of 2 minus 6 to the power of 2. So instead of 36, I wrote 6 to the power of 2. Instead of x squared, I wrote x to the power of 2. And this is just a square minus b square. First term square minus second term square. I mean the square root of the first term and square root of second term. And I can use this identity and say this equals to x minus 6 times x plus 6. This is the factored form of this expression. That's how we use difference of squares. Let's do the second one. I have 9x squared minus 49. So first I have to check and see if these two terms are perfect square. So 9x squared, if I square root it, square root of 9x squared, I get 3x. It's a whole number and a variable, so 3x. I know 9x squared is a perfect square because I square rooted and I got 3x. And 49, if I square root 49, that gives me 7. So I know 49 is a perfect square as well. So if I want to factor it, I can write it as, based on this identity, I can say this equals to the square root of the first one, which is 3x, minus the square root of the second one, which is 7, times the square root of the first one, plus the square root of the second one. So this is a factored form of this expression. So that's how we use difference of squares. Thank you for watching.